I got the chassis on its side and unscrewed the sheet metal screws holding the bottom on. Not too dirty inside, just a few old bits of bugs and leaves and whatnot. And here it is. And I'm happy to say no surprises so far. No mouse hotels, no bug infestations. And more importantly, I don't see any parts that have burned out or exploded or anything. Some dirt there. A little bit of wax oozing out of this, which is probably the vertical output transformer. But I don't think it's too bad. It's probably just from heat during normal operation. Flyback looks okay, but I'll have to double check that for sure. So these Motorola sets are a little bit unusual in that they put the flyback and high voltage rectifier underneath the chassis rather than on a box on the side like most sets have. Oh, there's a little sticker on here that says "Do it right." I noticed that in one of my other Motorola sets. Some other guys online have noticed that too. We think that maybe they were making mistakes in the factory, so they started putting these stickers on to encourage the workers to pay attention. No idea what all these numbers mean. It's like 13, 21, 28, 19. So what have we got? Let's start at this corner. Here is the channel selector. Motorola used kind of cheap wafer switches on these. And all these exposed coils here, those would be for the local oscillator and filters to pick out each individual channel. Got to be careful not to bump into these or you screw up the tuning. And then we've got various IF stages going down through here. These would be the coils that need to get tweaked if I do an alignment on this. Up here we've got the power supply. It's right opposite those capacitors. So this set does have a hot chassis and uses a voltage doubler right on the AC line to supply B+ voltage for the set. So that's these two rectifiers and this capacitor under the paper cover here. Those form the voltage doubler. I'll be replacing these with silicon diodes, but I'll probably just leave these mounted in here for appearance sake. Various controls along the back for brightness and linearity and so on. As I said, there's the flyback. And this would be the vertical and horizontal sweep stuff down in here. And this, this is the only evidence I've seen of any repair. I think these are 3 power resistors strung in series to get the right value. There's a bit of plastic, just loose in there. No idea what that might have come from, but I'll hang on to it in case I figure out where it goes. Well, otherwise, it looks to be in good shape. Oh, now here's the power and volume control. And I think brightness or contrast. So I've got 3 can electrolytics to rebuild and try to repair that broken wafer there, and then a whole lot of paper caps to replace. I found the service info for this set in this Wallace Tele that covers 46 to 53 or Motorola TVs. It's a TS53. They made a lot of variations of the TS series of chassis. I think it's starting with TS-4 and it goes all the way up, like into the 400s, maybe more. They're all pretty similar. So here's that power supply. It's a little unusual. So here's the power that comes in, and as you can see on the other side of that switch, it just goes right to this line here, and this is the chassis. So this is definitely a hot chassis, so I got to be really careful, use an isolation transformer when I work on it. And then there is a power transformer, but that's just for the tube filaments. It's a little unusual too in that there's a tap on the primary to heat up a 25L6, the vertical sweep output tube. So it's a 6.3 volt filament on this side for all the tubes. But this one is tapped off the primary for 25 volts. And it looks like V20, the pitcher tube and one other tube get their own dedicated winding. I guess that was to provide as much protection as possible to the pitcher tube filament. And there's another separate little outboard transformer here for V18. That is the 6W4 damping tube. These have a lot of voltage on them. You can see it's 460 volts on the filament. So the damper tubes usually have their own dedicated filament winding separate from all the other tubes. And then here's a voltage doubler. So there's that electrolytic that's under the paper cover. The reason they did that is so you don't get shocked if you accidentally were to brush your hand, say, against the metal outside of the can, because both the positive and negative on that can are at full line potential. And those are the symbols for the selenium rectifiers. And then there's one filter electrolytic, then there's a speaker field coil, and then there's another electrolytic. And that forms the power supply. Everything else is pretty straightforward. There's tuner, oscillator, mixer, and the IF stages. And this is nice in that it has inter-carrier sound. So you go through all this video detector, video amp, and there's a little 2.2 picofarad cap here, and that is the sound pickoff at 4.5 megahertz. So you got 6V6 audio output, and that should provide some decent volume. One thing that's kind of odd though is it has a 6J5 for an audio amp and a 6J5 for vertical sweep. I've never seen a 6J5 on a TV before, only some radios. And so on. Let's see. It doesn't look like this set has DC restore. I think that'll be the first set I've restored that doesn't have it. That would be a rectifier that would go in here. It provides better black and white levels for the picture. Oh well. Alright, so I'll get this chassis up on the workbench and start looking at it. I accidentally recorded over some footage I had recorded while working on this set. I'm going to do my best to recreate it. Just ignore the fact that there's already been some work done on it. So I got the chassis up on my workbench and I undid the screws that held on that iron band that was holding the picture tube in place. The rubber padding had really fused between this metal and the CRT, so I had to use a putty knife and carefully pry it free. Same down the bottom here. But eventually I was able to carefully slide the CRT out, and I put it over on the side there out of harm's way. Next I wanted to make sure that the yoke and the flyback and some of the transformers were good. There's no sense in spending all the time and money and effort to replace all the capacitors only to find out that a critical hard to replace component is fried. So to do that I used a combination of an ohm meter and this handy ICO 944 flyback and yoke tester. Some of the some of the transformers on the schematic, like this flyback, they have the resistance labeled. So I used my ohm meter and measured these various points, and the readings I got were pretty darn close to what they had labeled. But that's not the whole story. It is still possible to have some shorted windings and the resistance might be pretty close. That's where this comes into play. I'll flip this chassis on its side and show you what I mean. As far as working on the chassis, Some chassis are harder than others to kind of flip on their side or flip upside down and work on. Like this one, I can't just turn it over because all the weight would be here and the thing would just be flopping all around. So you could build a wood frame on a 2x4s. I usually keep a supply of random length ones lying around so I can cobble together a jig to hold it. But in this case, it works out pretty well with this transformer here. It's a little bit of a gap, and if you put something like a soft cloth here, it rests quite comfortably on its side. Remember, with the CRT out and this itty-bitty power transformer, this really doesn't weigh all that much. So I can simply do that, and it's not going to fall over, it's not going anywhere, and it's all quite well exposed. Now, the way this works to test flybacks is first you turn it on, let it warm up, and you can test continuity with it, but that's what I did with my ohm meter already. That'll just tell you if a winding on the transformer is totally open or if you have continuity. The more critical one is shorts, or I should say, once you know you've got continuity, you can just do that with an ohm meter. The short one is the more interesting one. There are two common types of flybacks, air core and iron core. This one is iron core. That's what this thing is in here. It's powdered iron compressed into a form, and it's actually like a square, and there's a high voltage secondary here and a primary on this side. What this thing will do, it will detect a single shorted winding anywhere, like on the secondary. There's thousands of turns of wire in there, and if there are a couple shorted, say near the outside, it might not affect the resistance that much, but a few shorted turns can really throw off one of these. They're meant to work at a precise frequency of 15.75 kilohertz. That's the horizontal scan rate in a television set using the NTSC standards. So what this will do, I believe, is generate a signal and feed it into the flyback at that resonant frequency. And if things aren't quite right, you have a meter deflection of the bad range. There are two positions here for iron core. When you do the shorts, you want to be over here. For continuity, both types you put over on this mark. So I've got it pretty well set there. Two test jacks here. They call one ground and one test, but really it doesn't much matter for the shorts test. You can connect the leads either way. Now, as far as where you attach them, one goes to the plate cap on the rectifier tube, and the other one goes to the plate cap on the horizontal output tube. You also have to remove the high voltage rectifier tube, and you have to disconnect the horizontal flyback winding, because that is connected right to the flyback, and that will throw off the readings. So I've already done that. I just need to grab some test leads and I'll hook it up and I'll show you how this works. Alright, I've got a test lead clipped onto both plate caps, and now I'm going to connect it here, and see the needle deflects up into the good range. So that tells me it should be good flyback. Now you may hear that high-pitched sound. I've heard that before when I've tested flybacks, and in normal operation you don't hear that sound, or at least it's nowhere near as loud, so I'm not concerned about it right now. Be careful when you're doing this. Even though this test signal is fairly low level, this flyback will amp it up hundreds if not thousands of times, so you can get a nice little jolt if you touch the wrong lead while you're doing this. Similarly, you can also test the yoke windings, horizontal and vertical. I've already checked them for continuity and they tested okay, so I'm not going to worry about it too much. Because to test these, you have to disconnect some of the components in here. Like on the vertical deflection, there's a 560 ohm resistor across both coils. You have to remove those to get an accurate test with this. Those resistors are buried inside that yoke, and I really don't want to deal with it. Oh, by the way, I discovered that this yoke is a replacement. It's pretty obvious when I looked at it because all 4 leads are spliced into the old, and the colors don't match what's on the schematic. So I just hope that they used the correct yoke when they replaced it. I don't see a model number on it. Or, I guess there is, but it's kind of really worn out, so I'm not sure what if that was an exact Motorola replacement or what that's all about. So I'll just keep my fingers crossed on that. Similarly, I ohmed out this little transformer, which it turns out is the transformer for both the damper tube, that's these 2 leads here, and for the picture tube and one of the AU6 tubes in the audio stages. And I also checked that power transformer, and it seemed to be okay. And the audio output transformer. And that guy there, that is the vertical output transformer. So once I knew all that was okay, I started going ahead with the recapping process. I started down here, and as I did each section, I would also test the resistors, and I have found quite a few that were out of spec. I'd say about half, maybe even more. I started working my way across here, and you can see how all these light blue resistors, these are all new half-watt 1% metal film resistors that I've used for replacement values. I removed that big glob of 3 power resistors. That was going between ground and the center tap on this focus rheostat. I think that was an attempt to compensate for the fact that this resistor was measuring off. It should have been 3.3K and it was only 3K. This is also in part of that focus rheostat circuit. That's all I could figure. It's not supposed to be in the circuit, so I just removed it. I put the right resistor in here, so I'll just hope that that works out all right. The only problem I've had so far is that while I was working on this 6AL5 tube socket, I flexed one of these socket leads a little too much and it broke clean off right at the bottom there. So what I did for now is I put a tube in the socket and I just soldered this lug directly onto the tube base, or sorry, the tube pin. So you can't pull the tube out right now. I don't know how well you can see that, but it's down right in here. So I believe that tube is good, so at least for me to power up this set, then it'll be okay, but eventually I have to replace that socket. It's not going to be so easy to do though. It's popped riveted on, and it's kind of an odd socket too, where one of the mounting points is a little bit of metal that curls around, and there's a post in the center that's connected to that. That goes to some of the pins, so I'm not sure I've got any sockets like this. If you ever do the same with octal sockets like this, they're not so bad, because you can actually straighten these out, bend that little pointy tab there in, and you can slide these out from the top, and then you can replace it with a new one of these. Not so much on these guys. They're sort of like split metal channels and they're bent over and fed through, so I don't know if I can actually repair a socket. Might just have to replace the whole thing. Otherwise, yeah, I've just been slowly working my way through this. I still have a few to do here and the section up here. For the 3 electrolytics, I'm going to rebuild them one at a time. This rat's nest of wiring in here is pretty complicated. So I'm just going to rebuild one, remount it, solder the leads in, and then move on to the next one. I just removed this guy a little while ago. That's the 100 microfarad, 150 volt cap. That's the one that goes right on the AC line. It's this guy right here. That feeds into the voltage doubler. That's why they put cardboard over it so you don't get shocked. This was stuck on there really good. I used a heat gun. I had to hold it on for quite a while to loosen up the tar inside, and I slid the cardboard cover off. Because this cap is inside a cardboard tube, I'm just going to cut it open near the base, put a new cap inside, and slide the cardboard over. It'll hide the seam. I'll glue it together with epoxy. The other ones, though, I will uncrimp the seam as I've shown in earlier videos and restuff the caps. I also removed the 2 selenium rectifiers just to get them out of the way so I can open up this area and get a better, get at those capacitors better. I just temporarily tacked 2 modern silicon diodes in place, just so I remember the orientation and where these wires go. I'm not going to leave it like this, that'd be very dangerous. But I'll save that until I get the caps rebuilt. And I guess that's about it for a status update. While I've been working on this, I've also started to do some work on the cabinet, and I'll save that for the next segment.